First things first, you see a name here, and it's Robert Brunner. Actually, the talk is from him. He's the master, I'm the apprentice, if you know the book. But nevertheless, he couldn't make it, so I just said I would take over the talk. I'm Carsten. I'm with Red Hat since 2016, and basically focusing on Kubernetes as an application platform. So, what are we talking about? Basically, or where do we start? If you go out here, you should have a good understanding of what multi-architecture means in regards to containers, what manifests are, IDs, digests, config files, stuff like that. Basically, you all will know this life cycle from containers, where we first create a container, then we push it to a registry and then pull it and run it, right? That's very easy. So basically, I assume you're all familiar with that stuff, so I really don't need to go very deeply into it. So basically, we're covering all this, except of the runtime, because this is really a different topic, and what we're interested in is basically done before runtime. So we have various tools. You might know the tools, namely supported also by Red Hat. Under GitHub/containers, I think you find a bunch of various tools to deal with the entire lifecycle, such as Podman, Builder, Scopio. Quay as a registry. Of course, there are others. And also the runtimes. Yuki maybe is interesting for people who are interested in programming Rust, because it's a Rust-based runtime. It's maybe also interesting to just have a look in case you need to develop something in regards to containers and just want to see how it could be done. Okay. To make images which seem to be immutable, or which are actually immutable, but sometimes, thanks to misunderstandings, behave not always as they are immutable. There are standards, and you will all know, I guess, the history with Docker, and then people jumped on the train and said, okay, this is too important that we do not standardize it, and people wanted to get into the boat, have something standardized so people could really trust in a broader ecosystem instead of one company. So we had the Open Container Initiative. You will all know this, and there are basically the specifications we are looking at and how it is done, basically. So we have the image spec, and this defines basically how an image is structured. There's also the image index spec behind that. Then we have something for the registry, the distribution spec, and finally a runtime spec. So it's all specified. You can look it up. It's on GitHub. And links are provided here in the slides. So basically, when we build a container, we can use tools like Podman and Builder. And basically what we have in the beginning is the container file or Docker file, where we specify something, then we create it, and basically it spits out a container image. You all know this. And now it becomes interesting. So what's in there? Basically, we have something like a manifest file, and we will just have a much deeper look into it. And the manifest file references to a configuration and various file system layers, where basically all the stuff you need to run your application is in various formats. You will all know this unified overlay FS stuff, I guess. So we're still in the first step. So we're locally now creating our container image. And let's say we are just now on an x86 machine, and we use our tools, and basically the tools create various SHA-256 values as digest values for us. So we have a separate value for the manifest, for the configuration, and for the various file system layers. Let's have a look at the manifest file first. So what you see there is a reference to Can you see this? Yeah, I think it's readable. You have a reference to or a digest of the config, basically. It's the 8.1b here, and then to different layers. And you also see that there are these media types, and they are actually used to reference the type of the information within the manifest files or the various specified files. So you see here in the very upper part, let's see whether this is working. Oh yes, it's working. Is it working? Yes. Here, for example, you see the media type of this entire file is the manifest itself. Then here is a reference to this one, and the media type actually is here defined as a config file. And here we have our file system layers, which are tar files, and they also have their digest values, right? And that's basically it. And we have also these annotations, but they're not of interest at the moment. So let's jump into the configuration itself. And the configuration, you just to remember, we had this char value here. Oops. Or maybe I'll just, you see this 81b value. And we have the char value here, and basically this is created over this structure, which is actually a little bit shortened to be readable still. And yeah, this is basically how the configuration itself looks like. And you will, if you're somehow familiar with Docker files, will recognize things like env, the command, some labels, stuff like this, and the architecture and so on. Normally, tools which create container files locally directly recognize the architecture they are running on, so this will be done all automatically. And you, of course, you normally should never be forced to fiddle with the configuration, for example, because the tools are doing it, unless you are an engineer who really creates container tools, which is sometimes maybe also possible. But these people are rather rare. I'm not sure how many engineers are here. So then we also have the links to the div IDs, which are actually not the same as the digests of the manifest file, but just for the untarred content of the various layers here. Just to make this clear, so what you have, here as the layers, yeah, the tar values, this is not the same in the div IDs. Okay, we are still in the runtime, so we had this, and now if you run something like podman images, digest or trunk, I think with Docker inspect you can also do parallel things. You will get a digest value. Now it's working. A digest value and an image ID, right? And this is actually, this is interesting. So just stay with me with the 66A and the image ID, the 81B, because later on we might need this. So basically, we have created a very simple container, and locally, and now we see that some values were created, basically, right? So. And you see now how these things link together. So you remember the entire manifest file, and the char value of it is actually what then here is the digest, right? So this value is basically the manifest file. And the manifest file, just to make sure, links also to the file system layers and the configuration. This is one thing, and you also might recognize the 81B again, and the image ID itself. This is the configuration. This is quite important. We will very soon see why this is so. So I hope this is clear for everyone. Now, so now we go one step further. Oops, somehow it's different. Anyway, and we push the image to a registry, in this case to Quay, and we have Scorpion. Now the interesting part begins. You remember we had a manifest SHA value with 66A, and now it's 765. It's different. And I just met one person here, and they just also found out that how this is working, or not maybe how this is working, but that it is working like this. And basically, when you create something locally, you would expect that the manifest SHA value is the same, so the digest is the same, but it's not. It's actually changed when you push to a registry. So in a way, it's scary, right? So I find it a little bit scary. So let's have a look also here at what we have here. So you see the manifest, the digest basically has changed to 765 here, which is not so nice. Fortunately, the configuration, so the image ID itself, SHA value remained the same. Of course, when you change something in between, also this will also change. But basically, this remains the same, and this is basically also something later on in your workflows you should consider to, for example, prove origins and so on and so forth. So let's have a look at why it is so. And if you see this, for example, this example of the manifest from our registry, we see that the media type actually has changed. And this basically results in a different digest value compared to what we had locally, because here now it's gzipped also, and this basically results in a different digest value. This is important in a way, because I mean, intuitively, everyone would say, well, containers are immutable. I have my container here, I push it to the registry, and the digest value just stays the same. But it's not, right? So it's interesting, right? I think so. And what you would do then is basically use, if you want to work with the digest values, your starting point always should be then your registry. So much to this. Yeah, I just want to, what we have here. So basically, yeah, this is again the same. Okay, now we run the container image. And yeah, now we just go to this step. Are there any questions also? Is it okay to have questions here? Or okay, guess so? No, anyway, okay. Now we just go to run the image, and we on a x64 machine, and basically, yeah, what we expected is that when we create on an x64 machine an image, it should also run on another machine, right? Now we try to run the image on an ARM machine. Actually, I could also look at this screen. That's funny. But what we see here, it's that it's not working. But actually, from my understanding in the very beginning, if I create locally an image and I push it and I try to run it on a different architecture, I would expect that it's not running automatically. Maybe you're very used to it, that it's always running, but the reason behind it will just come very soon. So if we do the same as before, so we create and build and push the image, we have the same behavior, of course, that the digest value is not the same as we did locally. Nevertheless, yeah, we can just run it and push it, and of course, when we build on ARM64, it will also run there. That's, I think, quite self-understood. Of course, if we try to run it now on an x86 machine, of course, it's also not running. So, and this is why multi-arc images come into play. And basically, the specification behind this is the image index specification, and what it's done here is basically we put together the two specifications or the two manifests of our images for the different architectures, and create a new manifest based on this linking basically to these different images. It's also called image index. I think in Docker times it was manifest list, and it's also called fat manifest in the specification. And basically this is how it works. And of course you can add many more architectures, as many as supported into such an multi-architecture container image. Basically, this is how it works, and it's quite self-understandable. And this fat manifest, of course, also gets a new digest value, which then can be referenced and should be referenced to. So basically, it's like with Podman, quite easy to create it. So assume you have already created your various images and pushed them to the registry. You just create a new manifest with Podman manifest, for example, and then you just add, basically reference the existing images to it, and then you push it to the registry. It's that easy, actually. Yeah, and basically it looks then like this. So you see here again, so we have here now this media type of image index, right? And it's referencing now to these image manifests. And you might remember we had this pushed digest value, and it's just directly referencing it to it. It shows the architecture here and here for the ARM. So basically, that's how it works. Oh, it's quite fast. So if we now run this image, both on, you see here, it's an x86 system. If we now run the multi-arc image, it's of course working because it's referencing also to this architecture, but also the same is also running on an ARM machine. So basically, that's how it works. And normally the container runtimes look at platform architecture OS and maybe also version for Windows environments. I'm always looking at this. I should look over there anyway. And basically, this is how it works, right? So the runtime looks up the environment and then just sees if it's possible to reference an image. Sure. Basically, yeah. Oh, maybe you just.
Because usually you have their platform architecture, OS, and variant, and I was missing the variant in there, so I was wondering if Podman is skipping, or any Red Hat container runtime is skipping the platform variant for image selection.
I'm not sure whether it's really according to the runtime spec. Is it? I'm not sure whether it's mandatory. Therefore, I'm a little bit. Okay. Okay, I rather take this as a suggestion because I can't really answer it. As far as I just know, these three things are normally taken by the runtimes, but I'm not that deep into the code to just know it. But so the thing is, if there's a platform variant, it should be considered by the runtime. Would you mind to give an example? I mean, it's interesting for me also. So, is it okay? Yeah, okay, sure. So where you would think it's useful to have a variant?
Because the version of ISA of CPU, like which generation of CPU are you running with, it includes what kind of features are included in the CPU as well. So you, for example, have ARM v6, so you can have new builds with ARM v7, and compatibility between different ARM versions might be hard. And that's why you have this kind of information also added to the index where you have platform architecture, OS variant, also for AMD 64 CPUs as well. So yeah, it's basically just a variant field of the CPU version, right? That's what I...
Thanks. Makes absolute sense to me. Namely, if you have, specific functionality you could use in the runtime, depending on, newer processes or so, then yeah, would make absolute sense. But I think it's not mandatory as per the specs. But I really had to look it up. Thank you. Yeah. Okay. Yeah. Okay. So, what do we have here? This is now an overview of the Quay UI actually, and basically of the images we have created here. And you basically see here the multi-arc image. Has these references to this. Actually, I think every registry will somehow show this if you have a multi-arc image, basically. So, one question is, can you have also, you can have, of course, multi-arc, but can you also have multi-OS manifests? And actually, yes, you can have them. So basically, here's an example of a manifest. And it's also referencing here, Windows versions also. You see this. Actually, yeah, I was always wondering why it's twice here, but it will have a reason. Anyway, sorry, but I just see this, here it's 2 times. And it's just because there are actually different versions of Windows, and they're referencing these 2 versions. Don't know why. Actually, I'm not working often on this operating system. So basically, then one question was, and Robert seems to answer this quite often, whether you can also build multi-arc images with Tekton. Why shouldn't you? Nobody hinders you creating in any arbitrary CI/CD tool to create multi-arc images, basically, right? You saw the commands. So basically, that's it. I actually can show you and talk to it a little bit, a little demo. Actually, it's in this case just a video demo because, I wouldn't be able to work here anyway. So what we see here is actually can you see it a little bit? I think so. So what's done here is there is a local registry deployed. Actually, you get all the links to the GitHub project behind this talk, as well as other information. And it's possible to just log into the OpenShift instance via OCRSH and then access the file system. And there, actually, what's been done is he's going into the blobs and is looking for the one image he has created. So he's there, and then he looks what it is, right? So it's already a gzip compressed data, this specific image, and he creates the char value of it. Now he copies it to another file, ungzips it, and creates another char value of it. And this basically is how you could explore, if you want to, images and just calculate the char values on your own, if you're really interested in doing such stuff. Yeah. Basically, that's it. And yeah, we're a little bit ahead of time, but I think you will love another break. And if you have questions, go ahead.
Yeah, let's do a couple of questions. Also, I see a duo talk forming between the 2 of you. Yeah, let's do a round of applause first for the speaker.
Thank you.
All right, let's see. Okay, first question in, why are you adding architecture suffix to tag instead of relying on the image index, meaning you can have different arc in the index for the same tag?
Could you please repeat it?
It's also up there, if that helps.
Architecture to tag instead of relying on the image index, meaning you can have different arc in the index for the same tag. I think it was just, just to be able to show what we are talking about. It's just for didactic purposes. It's not really like a best practice or so. Actually, I mean, you all will know and have understood now if you have a tag is pointing to a specific digest value, right? And this actually means you can also change the digest value behind the tag. So yeah, tags are mutable, and basically it's yeah not good practice in my understanding to work with tags in terms of have the final and ultimate version of a specific image, right? You always should use the char values, right? In this case, basically, the image ID is maybe a good idea first to start with.
All right, thank you. Let's go to the next one. Can consistency across architectures be guaranteed if there is separate manifests? For example, if I test on ARM64, is there a change that fails on the other one?
Is there a code? You mean you create an image on ARM64 and test it, and then you create just, I mean, like automatically an image on x86, for example. Actually, I would test all the architectures I have, definitely. I mean, this would be my best practice always. So whenever the surrounding environment changes, you should test it, right? And have a separate test for it. I would never do it and never trust on it that it will work. Never, ever. So
It sort of never, ever just works, does it? Unfortunately. Let's see if we have any more questions. I sometimes need to hard refresh because it's not working super well for me. Let's see, we have another one. Okay. Why does the pushed image format change, and does that mean that the image size is different?
Okay. Maybe I didn't explain it or was too fast enough. So actually, when we pushed it, you might remember that what we had locally was a tar file system layer, and now we have a gzipped. And that's basically the reason why it changes. Maybe that's also quite interesting. Robert has spawned a discussion regarding whether it's somehow possible to predict the new digest value. And I also had a talk. The thing is, you can't so far. As I understood, our engineers, it's just not possible to predict the digest value that will come from the registry. So, in sense of best practices, I would always recommend use what you have on the registry first and take this as a starting point to, I mean, deal with the images, right? I mean, you can test locally and so on, but what should go to others should always come from the registry.
Perfect, thank you. We have no further questions, but maybe people are still typing and it's not going fast enough. So I think you can still find Karsten for the rest of the day. Are you staying for the social? Can they find you for more questions?
Not.
Oh no! I was hoping you were just going to say yes, obviously. All right, but you're going to still be here for a little bit.
Yeah, sure.
And we start again with the next talk in 15 minutes. So thank you. Let's do one more round of applause.